Floating head there. Sorry. Welcome back, chemistry fans. This is the solution video for Unit 4 exam. Want to try and go briefly through the process of how you make the corrections, and then we'll start right in with the solutions to each one of the questions. Okay. So bottom line is you're wanting to improve your score, and how you go about this is you create some separate document that you will turn into the Canvas assignment that's on your new page. And what you're going to do is you are going to make corrections, but that's the easy part because I'm giving the solutions here. So the answers are really not what's the important part. It's the part B, the second part here. You have to prove to me that you understand the content as you are seeing where you made your mistake, where your answer key differs from my answer key. You've got to ask yourself the why. Why did you need to make those additional steps? Why is there an H needed here? Why is mine not correct? And why is this the correct? So you have to analyze it. If I do not have the sense that you understand the content, you will not get full credit. It is not about putting answers down. Do not be mistaken. It is about you proving that you understand the content. So put thoughtful analysis into every single question that you miss, regardless of how insignificant it is. Tell me why you missed it. Tell me why this is the new correct part to it. And then the last step is whatever thing that you seem to be missing the most of. If that is balancing a redox, go find one and practice it. It can be one of my homework problems that you've never done, but you must show your work along the way. It can be something that you Google out there. But if all you're doing is just Googling and cutting and pasting, you're missing the point. Again, you're trying to learn from the process, so prove that you have learned something. All right, let's jump right in now. Share my screen. And we will get right into the questions. All right, the first one is you have to be able to tell me what type of reaction this is based on what you see just in this small portion of the reaction. You're only given the reactants. And so you have Al, aluminum, and you have iodine. There's only one material on the left. That tells you that this is a decomposition. This is a decomp. How do you know that? Again, this is if you missed it, you need to tell me how you know it. The evidence is there's only one material on the left. All the other types of reactions, they all have two materials on the left. This is the only one that has one material on the left. What's it going to break apart into? You have to know that it's going to break apart into two equal portions. Some of you made it as Al and I plus I2, thinking that that would balance it. But what you didn't think about is how then the charges are not balanced. So you would end up right where you left, Al1, I3. That's why that is not correct. That is why iodine is diatomic. It must be by itself. Now, at this point, though, it's not balanced. We have 3 on the left, we have 2 on the right, so we need to crisscross, flip-flop those charges. We need to put a 3 there, put a 2 there, and then that would mean to balance out the aluminums, you need a 2. All right, moving on. Number 2. This one, what we should notice is that it has one single element by itself on the left, and it has a compound on the right. That makes this one a single replacement reaction. The double replacement has 2 compounds. A combustion would have oxygen by itself. A synthesis would have 2 elements by themselves. So this is the only material that you're going to see that has the single replacement pattern. What you have to then see is that this is a metal and this is a metal. They are going to be the ones that switch places. So what we would end up with is calcium carbonate as one of the compounds and tin as the other material. Now, we must go and look on the periodic table and figure out the charge of calcium is +2, the charge of carbonate is -2. If you just write those down and it's because you missed it, you need to tell me where you got that information from. You need to prove to me that you understand that calcium is in the second column, so it has a charge of +2, that you have a cheat sheet that I provided to you that has all of the polyatomic ions with their charges available to you. You need to state that emphatically. If I have questions that says you just copied this down from this video, then I'm not going to give you full credit in speaking. Now, there are 2 of the carbonates. We need to put a 2 as the coefficient for this compound, meaning, though, that I have 2 calcium, so there needed to be a 2 right there. This is now balanced. Moving on to question number 3. There is not one single element by itself, but what you should notice, it is a double replacement, but specifically, it is a neutralization. And it is neutral because there is an acid. You need to tell me what makes it an acid, and there is a base. You need to tell me what makes it a base. And those two parts are going to crisscross. The metal is going to exchange with the metal. So I will end up with BaSO4 plus HOH. Now, this should be written as H2O because you should recognize that it does make water. But in the interim, we'll just leave it as it is because that would help you to make a balance. So it's not H2O2 because that needs to be reduced down. And then when you reduce it down, it needed to be balanced. So there should be a 2 in front of the H2O because you have 2 of those materials. Now, the Ba and the SO4, they already are balanced as far as their charges are concerned. Again, you need to tell me Ba is in the second column and SO4 is on your cheat sheet, and those have already balanced. Everything else is good at this point. Number 4, oxidation state for chlorine. All right, each chlorine. So what we need to do is calculate it. There is a rule that states from your cheat sheets that oxygen has a charge of -2. Calcium has a charge of +2. All of the alkaline earth metals have a charge of +2. So if we total that up, that's a +6, and that is a -18. So the chlorines in the middle, they've got to somehow make all of this equal to 0. So that means the 2 chlorines must be equal to a total of +12 because 6 plus 12 equals 18. 18 minus 18 equals 0. So each of those 2 chlorines, 12 divided by 2 means that each of them is a +6. It's not a -6. It's not a 6. It is a +6. You need to have that regarded in your answer, that you understand that it is a positive, and it is not a positive. You've just put a 6. I don't know if you meant positive or negative, so you must put positive. What is the oxidation state for every iodine that is elemental? Any element by itself that is elemental has a charge of 0. Nitrogen, same process as before, but this time, instead of it equaling out to be equal to 0, it's going to be equal to +2. Now, there is a rule that says that all of the hydrogens must be equal to +1. Each of the oxygens must be equal to -2. So that's a total of -6. So I've got 3 plus x minus 6 equals +2. So in here, what we've got to, oh, sorry, not +2, -2. -2. -2. So what we've got here is 3 minus 6. That would make this a +3 if it were to equal to 0, but it's not. It's equal to -2. So in other words, we've got 3 minus 4 equals x. So my value for the nitrogen is going to end up being a +1. Because 3 plus 1 would be +4, -2 would give me -2. All right. Which element is oxidized? Which one is reduced? So when we have elements that are by themselves, they have a charge of 0. So we can throw those charges in right away. We know that hydrogens are always going to have a charge of +1. I know that halogens have a charge of -1. So right away, I have identified one of my elements that has changed their charge. The bromine has gone from 0 to -1. If you become more negative, you are becoming reduced. The other element that has changed is going to be the sulfur. The sulfur has gone from a -2 to a 0. And so because of that one, well, and of course, if you wanted to look, all the chlorines have rules, and that would tell you what the charge of the niobium is, and that's how we knew the charge of the sulfur, if you're wondering how I got to that. So because the sulfur has gone from a -2 to 0, that means it's become more positive. That means that the sulfur has been oxidized. So the sulfur is oxidized and the bromine is reduced. All right, number 8. In this reaction, what is the name of the role of chlorine? Well, chlorine in this problem did not change its charge, so it's called a spectator ion. Number 9, circle the reducing agent. So in other words, we're looking for the thing that's being oxidized. So if it's going from a +2 to a +3, that's the one that has gotten oxidized. Whoops, misspelled there. Which means it is the reducing agent. So it's the entire material, Fe plus 2. If you just put Fe, I don't know which Fe it is. So it's the Fe plus 2. All right, now we get into balancing the redox reactions. We have to write this into two half reactions. MnO4 minus 1 produces Mn plus 2. S2O3 minus 2 produces S4O6. So this has a 0 charge. Now, the manganese are already balanced, so I'm not going to touch those. Down in the bottom, the sulfurs, they are not balanced. So what I'm going to do is I'm going to have to double this. Now, in doing so, what some of you made the mistake is you forgot to double the -2 charge. We'll come back to that one in just a second. On the first one, I've got 4 oxygens. I need to add 4 waters to balance it. That's just the second step in this process. Now, though, I've created an imbalance of hydrogens, so I have to create 8 hydrogens in here. Because now I am all balanced with the elements, now I have to look at the charges. The charge on the left side is +7. The charge on the right side, all of this, is +2. So I got to make those +7 and +2s equal. I don't have to make them equal to 0. I just have to make them equal. So that means I need to add 5 electrons to the left, because 7 minus 5 gives me +2. Now they're both equal. On the bottom half, because I have -4 total here, I have to add 4 electrons to the left. If you make this mistake, don't just simply put an answer down. Tell me why. Explain why that coefficient applies to the charge as well. And then tell me why you made that mistake. You may have put a -2 in there. So now you need to tell me why it's supposed to be a -4. Explain the thought process. Don't just give me answers. All right, now what we look at is the fact that these 2 electrons are not equal. So I'm going to have to make a coefficient go to both of these to balance them out. And once I've done that, now I have 20 electrons. I have 20 electrons. I have 32 hydrogens. I have 4 of the manganate ions, 4 of the manganese ions, and I have 16 oxygens. On the left side, I have 10 of the S2O3s, and I have 5 of the S4O6. Put it all together in your final answer with the electrons being canceled out because they are the same on both sides. I would have 32H plus 4MnO4 minus 1 plus, 10 S2O3 minus 2, producing 4Mn plus 2 plus 5 S4O6 plus 16 H2O. Everything balanced, and that is your correct answer in acid. Now, on the next one, it's in a basic solution. So you have one additional step that we'll have to deal with on the next one, but we start with the Cr producing Cr plus 3. Notice on this one, there's no other elements. The CRs are balanced. So what we got to do is make this equal to 0. So I'm going to add 3 electrons up here. Now it's balanced. IO3 minus 1. Whoops, it's on the wrong side. Let me write that on the other side. IO3 minus 1. And I have H5IO6 on the left side. Okay, my iodines are balanced, so they're okay, but my oxygens are not, so I'm going to add 3 H2O to this side. Because of that, I need to add 6 hydrogens to this side. Whoops. I need to not add 6 hydrogens. I already have 5 hydrogens. I only need to add 1 hydrogen to the left. I have 6 hydrogens here, and I have 5 plus 1 would give me the 6 that I need. Now it is balanced. But my charges are not, because I've got a -1 here and a +1 over here. So that means I need to add 2 electrons to this left side. In doing so, I now have created a -1 on both sides. All right. These are not balanced as far as the electrons are concerned. So I got to put a 2 coefficient here. I got to put a 3 coefficient here. So what we would end up with is 2 chromiums, 2 chromium ions, 6 electrons. I'd have 6 electrons, 3 hydrogens, 3 of these iodine compounds, 3 iodates, and 9 waters. Okay, put all this together. 2 chromiums plus 3 hydrogens plus 3 H5IO6 produces 2 chromium ions plus 3 iodate ions plus 9 waters. Here's the last step. Because it's in a basic solution, I must add the same number of hydroxides that I do for hydrogens to both sides. You can't do one without doing it to the other. It's just like algebra. But in doing so, this becomes 3 waters, which are going to cancel out with 3 of those waters. That is my final answer now. So I have the same material, the chromiums, the iodine, the chromium, the iodate, but now I have only 6 waters and 3 hydroxides because this is in a basic solution. Okay, number 12, last question. Explain how the chart works. So in your chart, somewhere in the middle was hydrogen. And then you had very reactive metals and you had lower reactive metals. For you to make a reaction, lithium plus gold carbonate, I don't even know if that exists. Will this reaction occur? Yes, because the higher element on the chart, it is higher on the chart than the element it's replacing. So this could make lithium carbonate and separate the gold out. But what if we did this in reverse? If we had, say, lead down here. If we had lead plus lithium carbonate, it will not occur because the element is least reactive on the other side. So this will not produce a reaction. All right. Thank you very much for your time. I hope this explains all of the solutions. Do with it what you will. Make your corrections before the end of the quarter. Thank you so much. Farewell.